Are you looking for important questions for max paper for your school board exam? Are you looking for a place to find such questions and its detailed explanation? Yes, this is the right place for that. Hello, I am Rajesh Bhaskar. Welcome to our channel, Be More. Here you can find questions and its solutions in various categories like MCQ, FIB, very short answer type, and long answer types. So, let's get started.
This video shows you questions in very short answer types and multiple choice questions which are more likely to come for the examination. First we jump into very short answer types. Before going to the first problem, a small request. Please note down those questions whichever you feel difficult in your notebook. This will help you during exam preparation times. Question. Show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear. So first we should know what do you mean by collinear vectors. Let's say we are having two vectors. So two vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitudes and directions. We can also say that they are parallel to each other. Now the question is how to prove two vectors are collinear. One easy method is that if we can able to express one vector as a scalar multiple of other vector, then we can say both the vectors are collinear. So in this question they are given two vectors. So we can denote vector A as 2i minus 3j plus 4k and vector B as minus 4i plus 6j minus 8k. Now if you take minus 2 as a common factor from vector B, we can express it as minus 2 into 2i minus 3j plus 4k, which is equal to minus 2 times vector A. Since we can able to express vector B as scalar multiple of vector A, we can say vector A and vector B are collinear. Next problem. Find a unit vector in the direction of vector A is equal to 2y plus 3j plus k. So in this problem they have given one vector and they are asked to find its unit vector. Now how we can able to find a unit vector in the direction of a given vector? Let's say vector A be a non-zero vector. So if you take its modulus, we'll get a positive value other than 0. Correct. If you take its reciprocal, we'll get a finite value and we'll mark it at lambda. Now what is modulus of lambda vector A? It can be written as modulus of lambda into modulus of vector A, which is nothing but 1 by modulus of vector A into modulus of vector A. Modulus of vector A and modulus of vector A got cancelled and we'll get 1. Since we get modulus of lambda times vector A as 1, we can clearly say lambda vector A is the unit vector of vector A. Here one point to be noted is that since lambda is positive, the direction of lambda vector A is same as that of the given vector A. So the method of finding a unit vector of a given vector is by multiplying that vector with the 1 by modulus of that vector. That is 1 by modulus of vector A into vector A. Now you know how to find the modulus of a given vector. Let's say vector A is equal to a1i plus a2j plus a3k. Its modulus is given by square root of a1 square plus a2 square plus a3 square. So in this case, modulus of vector A is equal to square root of 2 square plus 3 square plus 1 square, which is equal to 4 plus 9 plus 1, which is equal to root 14. Now unit vector can be found out by 1 by root 14 into 2y plus 3j plus k, which is equal to 2 by root 14i plus 3 by root 14j plus 1 by root 14k. Next problem. Find a vector in the direction of vector r is equal to 3i minus 4j, which has a magnitude 9 units. Here we need to identify another vector which has got a magnitude 9 units. Also, it should be in the same direction of given vector. For this, we need to find its unit vector and then we need to multiply with 9. Now you know how to find its unit vector, correct? It is given by vector r divided by modulus of vector r. So modulus of vector r is equal to square root of 3 square plus minus 4 the whole square, which is equal to square root of 9 plus 60, which is equal to root 25 is equal to 5. Now unit vector in the direction of vector r is 1 by 5 into 3i minus 4j. As said before, the required vector which has got a magnitude 9 units and also in the direction of vector r is given by 9 multiplied with the unit vector, which is equal to 9 by 5 into 3i minus 4j. This is yet another video of the series showing solved problems of plus 1 plus 2 mathematics paper. If you are here for the first time, consider subscribing in order to get all other videos at the earliest. Next problem, let A is equal to I plus j plus k, vector B is equal to 2i plus 3j, vector C is equal to 3i plus 5j minus 2k, and vector D is equal to minus j plus k. Prove that vector B minus vector A and vector D minus vector C are parallel vectors. So, in this problem, you should know vector addition or vector subtraction and also the condition for the parallel vectors. Now we will see how to subtract two vectors if they are given in component form. Let's say vector A is equal to a1i plus a2j plus a3k and vector B is equal to b1i plus b2j plus b3k. Now vector A minus vector B is given by a1 minus b1 into I plus a2 minus b2 into j plus a3 minus b3 into k. Which means we take the coefficients of I, j and k and subtract each other to get the final result. So in this problem they are given four vectors and marked as vector A, vector B, vector C and vector D. Now what is vector D minus vector C? As said before, it is given by minus j plus k minus 3i plus 5j minus 2k, which is equal to minus 3i minus 6j plus 3k. If we take minus 3 as common factor, we can write it as minus 3 into I plus 2j minus k. Similarly, vector B minus vector A is given by 2i plus 3j minus I plus j plus k, which is equal to I plus 2j minus k. Now how to prove whether two vectors are parallel or not? As said before, let's say vector A in its component form as a1i plus a2j plus a3k and vector B in its component form as b1i plus b2j plus b3k. If we said that they are parallel, if we can able to write vector A is equal to lambda times vector B. That means it should be a scalar multiple of another vector. After calculating vector D minus vector C as well as vector B minus vector A, we can able to find out that vector D minus vector C is minus 3 times vector B minus vector A. Since vector D minus vector C is a scalar multiple of vector B minus vector A, we can clearly say that vector D minus vector C is parallel to vector B minus vector A. Next problem, prove that vector A minus vector B cross vector A plus vector B is equal to 2 times vector A cross vector B. You might have learned identities and its multiplication in early classes, correct? So in this, multiply each term of the first term with each term of the second. We get vector A cross vector A plus vector A cross vector B minus vector B cross vector A minus vector B cross vector B, which is equal to 0 plus vector A cross vector B plus vector A cross vector B minus 0. Here vector A cross vector A as well as vector B cross vector B is 0, since the cross product of similar vectors is 0. Now on simplification of the above, we get 2 times A cross B and hence it is proved. Next we will jump into short answer types. Next problem, find the area of the parallelogram whose adjacent sides are determined by the vectors vector A is equal to I minus j plus 3k and vector B is equal to 2y minus 7j plus k. So in this problem they have given two vectors and they are asked to find the area of the parallelogram. Assume that these two vectors are the adjacent sides of the parallelogram. Suppose if we can able to represent adjacent sides of a parallelogram as vector A and vector B, then its area is given by modulus of vector A cross vector B. Now we can see how it has arrived. So as shown, this is a parallelogram ABCD and let the side AB be represented as vector B and the side AD be represented as vector A. Now you know how to calculate the area of a parallelogram. It is given by measurement of side into its altitude. Now how to measure its altitude? For that we need to draw a perpendicular from the point D to the vector AB and its meeting point be E. Now D gives the measurement for altitude. So area of parallelogram ABCD is given by AB dot DE. Correct. It is nothing but what? AB dot AD sin theta, which is equal to modulus of vector B into modulus of vector A into sin theta, which is nothing but modulus of A cross B. Thus we can see that area of a parallelogram with adjacent sides as vector A and vector B is given by modulus of A cross B. Now if two vectors are given in its component form, you know how to calculate its cross product, correct? Suppose vector A is equal to a1i plus a2j plus a3k and vector B is b1i plus b2j plus b3k, then its cross product A cross B is given by determinant ijk a1 a2 a3 b1 b2 b3. Now we can see how it has arrived. So A cross B is given by a1i plus a2j plus a3k cross b1i plus b2j plus b3k, which is equal to a1i cross b1i plus b2j plus b3k plus a2j cross b1i plus b2j plus b3k plus a3k cross b1i plus b2j plus b3k, which is equal to a1 b1 into I cross I plus a1 b2 into I cross j plus a1 b3 into I cross k plus a2 b1 into j cross I plus a2 b2 into j cross j plus a2 b3 into j cross k plus a3 b1 into k cross I plus a3 b2 into k cross j plus a3 b3 into k cross k, which is equal to 0 plus a1 b2 into k cap plus a1 b3 into minus j plus a2 b1 into minus k plus 0 plus a2 b3 into I plus a3 b1 into j plus a3 b2 into minus I, which is equal to I into a2 b3 minus a3 b2 minus j into a1 b3 minus a3 b1 plus k into a1 b2 minus a2 b1, which is nothing but determinant ijk a1 a2 a3 b1 b2 b3. So this is how it arrives. Now one more point also you need to remember regarding the cross product among unit vectors. So this is as shown: I cross I is equal to 0, j cross j is equal to 0, k cross k is equal to 0. Similarly, I cross j is equal to k, j cross k is equal to I, k cross I is equal to j, and also j cross I is equal to minus k, k cross j is equal to minus I, and I cross k is equal to minus j. Now coming to the problem, so vector A is given by I minus j plus 3k and vector B is given by 2i minus 7j plus k. So modulus of A cross B is given by determinant ijk 1 minus 1 3, 2 minus 7 1, which is equal to 20i plus 5j minus 5k. I believe you know how to simplify a 3 by 3 determinant. Please refer the determinant chapters. So area of a parallelogram is given by modulus A cross B, which is equal to modulus 20i plus 5j minus 5k, which is equal to square root of 400 plus 25 plus 25, which is equal to root 450. It can be simplified as 15 root 2. Next we'll jump into multiple choice questions. Next problem. If mod vector A is equal to 3, mod vector B is equal to 4, then the value of lambda for which vector A plus lambda vector B perpendicular to vector A minus lambda vector B is options: A 3 by 4, B 9 by 16, C 4 by 3, D 3 by 2. So in this problem they have given magnitude of two vectors and they mentioned that vector A plus lambda B is perpendicular to vector A minus lambda B. If that is the case, what is the value of lambda? Answer is option A. Now for finding the value of lambda, we can take the dot product. Since two vectors are perpendicular, its dot product will be 0. Similarly, here we can take the dot product of A plus lambda B and A minus lambda B and will equate to 0. So we can write A plus lambda B dot A minus lambda B is equal to 0, which on simplification we get modulus of vector A square minus lambda square modulus of vector B square is equal to 0. Now we can substitute the value of modulus of vector A and modulus of vector B in the above equation. We get 3 square minus 4 square lambda square is equal to 0, which on simplification we get 9 is equal to 16 lambda square. Therefore lambda is equal to 3 by 4.
So if you really enjoyed, give like and leave comments in the comment section below. Also consider subscribing for receiving other videos in the series at the earliest. Thanks for watching.